centimeters. Hi everyone, welcome to this video going over lesson 4.1, segments and angles. Let's get started with some vocabulary. An axiom or a postulate is a statement that is accepted to be true without proof. And you might be thinking, why would we ever accept something without proof? Isn't this a math class? Aren't we supposed to prove everything? Well, there has to be some foundation that we accept without proof in order to build upon. For example, if I asked you what a dog was, if you were supposed to define a dog, you might describe it as some sort of animal or a pet. And then I would say, well, what is an animal? And you would probably describe it as some sort of living organism. And then I would ask you what an organism was. I could keep asking you further and further questions. And so there has to be some sort of definition, some sort of statement that we accept to be true so that I can't ask you questions forever and ever and ever. For example, in math, these are point, line, and plane. These are definitions that we accept to be true without much proof. If you think about it, there's not really a way to define a point other than a dot, but we accept a point to be true so that we can build upon it and say when you connect 2 points, you form a line. Without that, we wouldn't be able to define a line. So an axiom or a postulate is something that we are going to accept to be true without proof. The other vocabulary word that we are going to talk about in this video is a midpoint. A midpoint is the point. So notice how once again this definition uses the word point. We wouldn't be able to do that if we had an accepted point to be true without proof. But the point on the segment that divides it into two congruent segments. Remember, congruent means having the same measure. So we are going to split a segment in half into two equal segments. So let's say I had segment AB. The midpoint would be some point M such that AM is equal to MB. Let's say they were both 3 units long. M would be the midpoint. Moving on, we have the ruler postulate. So there's a way of reading a ruler that everyone has accepted to be true. To every pair of points, there exists a unique positive number called the distance between points. The distance between any 2 points is the absolute value of the difference of their associated numbers. So for instance, point B is on 7 and point A is on 2. To find the distance between these 2 points, we are going to take the absolute value of their difference, which means we're going to subtract them. So if I did the absolute value of 7 minus 2, and remember, absolute value is like a negative magnet. The point of an absolute value is that whatever is inside the absolute value is going to turn positive. 7 minus 2 is 5. Since 5 is already positive, it can come out of the absolute value without changing. But the reason we use absolute value is because if I change the order and did 2 minus 7, I want to get the same distance between these points. 2 minus 7 is negative 5. So before taking that value out of the absolute value, I'm going to make it positive. And so the distance between points A and B would be 5 units. Let's see how distance looks on a segment. Now, since this is a video, I can't really show you how I measured this with a ruler, but take my word for it. I measured DE to be 4 centimeters, EF to be 10 centimeters, and DF to be 14 centimeters. And you might be wondering, Miss Felberg, you forgot the segment symbol when naming DE, EF, and DF. I did not forget the symbol. When I am talking about the length of a segment, we don't include the symbol. So DE without the symbol is referring to the length of DE. If I wanted to talk about the segment itself, then I would put the symbol on it. But when I'm referring to the measure of that segment, then I'm going to take off the symbol. And what I want you to notice is DE plus EF make up the entire segment DF, and their measures match that. When I add 4 plus 10, that equals 14, which is the entire length of the segment. And that is the segment addition postulate. If we have line segment DF and a point E within it, then the measure of DE plus the measure of EF equals the measure of DF, the entire thing. And we can use this segment addition postulate to find missing measures of segments if we know other pieces of it. So let's try examples of these. Use the segment addition postulate and the given information to complete each statement. Hint, draw a picture. There's a lot of points and a lot of segments. It is really easy to visualize the information if you draw a picture. So it says, if B is between C and D, so I'm going to draw a segment CD and put B somewhere in between them. Then it says that BC is 10 inches and BD is 3 inches. Find CD. CD is the entire segment, and I can find the length of the entire segment by adding those pieces together. So 10 plus 3 tells me that CD is going to be 13 inches long. Now, it's not always going to be as simple as just adding those lengths together, so make sure that you draw a picture so that you put the correct measurements in their correct places. Let's try B. If Q is between R and T, so I'm going to draw a segment RT and put Q somewhere in between them. RT equals 24 centimeters. Careful, RT is the entire segment. So I know that the entire segment measures 24 centimeters. And QR is 6 centimeters. Find QT. So I need to figure out what measure plus 6 will equal 24. So 6 plus QT is equal to 24. In order to get rid of plus 6, I subtract 6 to either side, and this tells me that QT will measure 18 centimeters. Make sure you are all including units with your answers. And lastly, if P is between L and A, so I'm going to draw a segment LA and put P somewhere in between them. PL is equal to x plus 4. So that segment is represented by the expression x plus 4. PA is equal to 2x minus 1. And LA is equal to the expression 5x minus 3. The problem says that I need to find x, and then after finding x, find the measure of LA. So what I'm going to do is I'm going to make an equation, because I know that LP plus PA is going to equal the entire segment LA. So I'm going to say x plus 4 plus 2x minus 1 equals the entire segment length, which is 5x minus 3, and I'm going to solve this. What I need to do first is combine like terms. So I have an x and a 2x, and a 4 and a negative 1. X plus 2x will be 3x, and 4 and negative 1 will be 3. I'm going to subtract 3x to either side. And then in order to get x by itself, I'm going to move this negative 3 by adding 3 to both sides. So I have 6 is equal to 2x, and then to get x by itself, I'm going to divide by 2 to either side. And this tells me that x is equal to 3. But we are not quite done, because the problem also said find LA. We know that LA is 5x minus 3. Please do not write 5x minus 3 as your answer. What it wants you to do is, now that we know what 3 is, plug in 3 for x to find out what LA really measures. So I've replaced x with 3. 5 times 3 is 15, and 15 minus 3 is 12. So LA is 12, and I'm going to use a little u to represent units, because they didn't give us units, so I'm just going to generalize and write units so that I make sure that I write units on all my answers. We're going to try this a couple more times, but now we're going to use the idea of midpoint. Remember, a midpoint splits a segment in half, so on either side of the midpoint, the measure should be equal. And I'm also going to recommend that we draw a picture for these as well. So given that M is the midpoint of RS, so for each one, I'm going to draw RS and M perfectly in the middle of the two of them. In A, it says that if RS is 10 units, so the entire thing is 10 units, what is SM? Well, if the entire thing is 10 and the midpoint is splitting the segment in half, then I know that each part is going to be 5 units. In B, it says if RM is 12, then MS would also be 12, because the midpoint splits it in half, and that must mean that together RS is 12 plus 12, which will be 24 units. And lastly, part C, if RM equals 4x minus 5 and MS equals 11 plus 2x, then what is RS? Well, let's think about what we know about RM and MS. Since M is the midpoint, I know that these two sides are equal to each other. So this will be my equation. 4x minus 5 equals 11 plus 2x. I'm going to start by adding 5 to either side. And then I'd like that 2x to join the 4x, so I'm going to subtract 2x to either side. And then to get x by itself, I need to get rid of that 2, so I'm going to divide by 2 to either side. And that tells me that x is equal to 8. But please read the question carefully. The question did not ask us to find x, although we did need to find x to move forward. The question wants us to find RS. So what I'm going to do is I'm going to plug in 8 for x in one of those two expressions. So 4 times 8 minus 5. 4 times 8 is 32. Minus 5 tells me that both RM and MS will be 27. Because since M is the midpoint, once we know one side, we automatically know the other. And to find RS, I need to add 27 plus 27. And so that tells me that RS is 54 units long. So hopefully you understand how to use the segment addition postulate, which says that the pieces of the segment added together equals the entire length of the segment. And hopefully you start understanding the term midpoint, which is a point that splits a segment perfectly in half, creating two congruent segments. And by knowing that a point is a midpoint, we know that the both sides of the midpoint will be equal to each other, and we can use the idea of midpoint and the segment addition postulate to find missing measures of segments. Please let me know if you have any questions, and I will see you in class.